Hey everyone, and welcome. Today we're jumping into something that's at the very heart of Java, operators. Seriously, think of these little symbols as the verbs of your code. They're what make things happen, turning your instructions into actual solutions. Let's get right to it. So, have you ever had that moment? You know the one. You're just staring at your screen, you've checked the code a dozen times, and you're thinking, this should work. But the output is just wrong. Yeah, we've all been there. And you know what? A lot of the time, the sneaky culprit is a simple misunderstanding of how an operator works. But don't you worry, by the end of this, you're going to be an operator whiz. All right, let's build up our foundation. We're going to start with the absolute core toolkit of Java operators. Like I said, these are the action words of the language. They're the symbols that let you do math, ask questions, and really make your code come alive. First up are the ones you probably already feel comfortable with, the arithmetic operators. You've got your basics, right? Plus, minus, multiply, divide. But don't sleep on that percent sign, the modulus operator. It is so useful for finding the remainder after division. Want to check if a number is even or odd? Modulus is your best friend. So what does this look like in the real world? Well, take a look at this snippet for calculating the area of a circle. You see how the asterisk for multiplication and the equal sign for assignment just work together seamlessly. They take some numbers, they do the math, and they store the result. It's simple, but this is the essence of what operators do. They process and transform your data. Now, let's talk about a real-time saver, assignment operators. Of course, you know the basic equal sign, but Java gives us some fantastic shortcuts, like plus equals or times equals. These let you perform an operation and assign the new value all in one super clean, super efficient step. And just look at the difference. On the left, x equals x plus 5. It works, totally fine. But it's a little repetitive, right? Now look at the right, x plus equals 5. It does the exact same thing, but it's way more concise. Honestly, getting comfortable with this is a huge step toward writing cleaner, more professional-looking code. Okay, now we're getting to the real brains of our programs, the comparison operators. These are your decision makers. They don't give you a number back. Instead, they give you a simple answer, true or false. This is literally how your code asks questions and makes choices. Every single if statement you write depends on these. All right, everybody lean in because this is a big one. This right here is probably the most common mistake for new programmers. Confusing the single equals, which assigns a value, with the double equals, which checks if two values are equal. If you mix these up, your if statements will go haywire, and you'll be pulling your hair out trying to debug it. Trust me on this one. So, what if you need to check more than one thing at a time? That's where logical operators come in. With the double ampersand, the AND operator, you can make sure two conditions are both true. With the double pipe, the OR operator, you can check if at least one of them is true. And that little exclamation point, that's the NOT operator. It just flips a true to a false or a false to a true. Simple, but incredibly powerful. You know, Java has this really clever efficiency trick called short-circuiting. Think about it. If you're using AND to check if two things are true, and the very first one is false, well, does the second one even matter? Nope. The whole expression is going to be false no matter what. So Java just stops right there. It doesn't even bother checking the second condition. That's short-circuiting. It saves a little bit of processing time, and it's a key thing that makes it different from the single ampersand operator. Okay, so we've met the whole crew of operators. But just like driving, knowing the parts of the car isn't enough. You also have to know the rules of the road. So in this section, we're going to cover the really critical stuff, the rules and common pitfalls that can trip you up. And this quote just hits the nail on the head. You remember PEMDAS from math class, right? Parentheses, exponents, multiplication, division, all that? Well, Java has its own, much bigger version of that called operator precedence. It's a strict set of rules that dictates the exact order things get calculated in. If you ignore it, your results will be completely wrong. Let's just walk through this example. Java doesn't just read this from left to right. No way. First, it hunts down any parentheses and solves what's inside them. Then, it looks for any multiplication or division and does that next. Only at the very end does it handle the addition and subtraction. You have to follow this exact order to get the right answer. Oh, this is a tricky one. This is a pitfall that catches even seasoned developers sometimes. Those little double plus and double minus operators. You can put them before a variable or after it. And it might seem like a tiny difference, but it completely changes when the variable's value actually gets updated. Let's make this super clear. When you write a++, that's post increment, Java essentially says, okay, First, I'm going to take the current value of A and give it to B. Then, after that assignment is totally finished, I'll go back and add 1 to A. So B ends up with the original value. If it was plus plus A, pre-increment, it's the total opposite. Java would say, first add 1 to A, and then take that new shiny updated value and give it to B. See the difference? It's crucial. Now, this pitfall isn't about a specific symbol, it's about being smart with your resources. In the bad code example, a brand new scanner object is being created every single time we need to get input from the user. That's super wasteful and can even cause some weird errors. The good code shows the right way to do it. Create one scanner at the top and just reuse that same object over and over. It's way cleaner, more efficient, and just better practice. All right, you are doing great. You've got the basics down, you know what traps to avoid, so I think you're ready for a pro move. Let's talk about the ternary operator. This is a really cool tool that can make your code look so much more concise and elegant when you use it right. Now, the syntax might look a little weird at first glance. I'll give you that. But it's actually really simple. It's always made of 3 parts. You start with a condition that's either true or false, then a question mark. After that comes the value you want to use if the condition was true, followed by a colon, and then finally, the value you want to use if the condition was false. That's it. So when should you actually use this thing? Well, this table lays it out pretty nicely. For really simple, quick decisions, the ternary operator is awesome. It's compact, it's clean, sometimes it's even a little faster. But, and this is a big but, if your logic is even a little bit complicated, stick with a good old-fashioned if-else statement. It's just going to be way easier for you and other people to read and understand down the line. And here it is in action. Look at this. We're actually chaining ternary operators together to figure out a letter grade based on a score. This one single line of code is doing the job of a whole block of if-else-if statements. Pretty cool, right? Just a word of caution. Don't get too carried away. If you chain too many of these together, your code can become really hard to read. Use this power wisely. Wow, we have covered a ton of ground. We've gone from the most basic arithmetic all the way up to some pro-level techniques. But listening to me talk is one thing. To really make this knowledge yours, you have to get your hands dirty and actually write some code. So before you start coding, let's just do a quick recap of the most important tips. First, if an expression looks even a little bit complicated, just use parentheses to make the order clear. Being clear is always better than being clever. Second, know the difference between your logical and bitwise operators. And finally, use good descriptive variable names. It makes your code 1,000 times easier to read. These simple habits will save you so much time and frustration. And that's a wrap. But now the real learning starts. It's your turn. The best way to lock this stuff in is to use it. So here's your challenge. Open up your code editor and try to write one original example for each and every operator type we talked about today. Play around with it, experiment, and see what you can build. Thanks for watching, and happy coding!